They are associated with the cellular respiration and source of the energy, and therefore the mitochondria is called as the powerhouse of the cell. Means in the mitochondria, the ATP molecules, they are synthesized by the oxidation and the reduction. Okay, means they are used in the cellular respiration. Okay, means all the cells, they require their own respiration. Okay, and for that purpose, the mitochondria, they synthesize the ATP molecule. Okay, and therefore the mitochondria is commonly known as the powerhouse of the cell. Okay, this is the introduction about the mitochondria. Okay, then next second point is the occurrence. Occurrence means they are found in those type of the cells. Okay, in this they are found in all plants and animals cell. Okay, means both the eukaryotic cell, that is the in the eukaryotic cell contain the two types of the cell, that is the plant cell and the animal cell. Okay, in this the mitochondria, they are present in both type of the cell, but they have exception, and exception is the absence in the mature mammalian blood cell. Okay, the blood cells, they do not have the mitochondria, and also the mammalian RBCs, they do not have the nucleus. Okay, and therefore also they are absent into the red blood cells. Okay, then to date only the eukaryote, that is the monoceromonads, that is the flagellates, is known to have completely loss of the mitochondria. Okay, one example, that is the monoceromonads, that is they are the flagellates. Okay, they do not have the mitochondria. Okay, or the absence of the mitochondria. This is the occurrence. Okay, then the next is the morphology. Morphology means the external appearance of the mitochondria. Okay, externally they looks like the filament. Okay, then first in the mitochondria morphology, the first is their shape. Okay, shape means their actual structure. Okay, in this they are variable in shape. Okay, means in the different type of the cells, they have the different type of the shape. Okay, then they are the granular or the filament. Okay, their shape is the presence of the granules, and also they look like the filaments. Okay, then the mitochondria are swelled out at one end to become club shape, also racket or the vesicular ring or the round shape. Okay, in the first line or in the first point, you see they are variable in shape. Okay, this is the first point in the morphology, that is the shape. Okay, then second point in the morphology, that is the size. Okay, in the size, they also variable in size. Then the size, actual size is the ranges from 3 to 4 micron in length and about 0.1 to the 1 micron in diameter. But they do not see under the light microscope. Okay, they require the electronic microscope for the observation of the mitochondria, because their size is very small. Okay, then the size and the shape of the mitochondria, they are affects by the physical and the chemical factor. Okay, means the size of the mitochondria and also the size of the shape of the mitochondria, it depends on the some physical and the chemical factor, or the chemical and the physical factors, they affect the size and the shape of the mitochondria. Okay, this is about the size. Okay, then next is the number. Okay, how many mitochondria are present in a single cell. Okay, in this the numbers are also variable from cell to cell and also from the species to species. Okay, means the number is variable in cells and also they are variable in the species to species. Okay, in some species their number may be more, or in some species their number may be less. Okay, in this they depends on the metabolic activity of the cell. Means the mitochondrial number, they depends on the metabolic activity. Okay, what is mean by the metabolic activity? In the metabolic activity means it is the metabolism. Okay, what is mean by the metabolism? What is the definition of the metabolism? Huh? Carried out by the cell. Okay, right. The means metabolism means the sum of all the reactions are carried out inside the cell. It is called as the metabolism. Okay, and the metabolism, they are divided into the two types. Right. First is the catabolism and the second is the anabolism. Okay, catabolism means complex food material get converted into the simple form. Okay, and the anabolism means simple food material get converted into the complex form. And in this, the catabolism plus anabolism is equal to the metabolism. Okay, and this metabolism activities, they requires the energy. Okay, and the number of the mitochondria, it depends on the metabolic activity of the cell. Okay, in this, the next point, the cell with the high metabolic activity have a high number of the mitochondria, and also the cell with low metabolic activity, the presence of the low number of the mitochondria. Means the more metabolic activity, then the more number of the mitochondria. Okay, less activity of the metabolism into the cell, they require less number of the mitochondria. Right? Metabolism means the reactions. Okay, reactions, and the reactions, they require the energy. Okay, then the metabolic activity is more, then reactions are occur more, and they require the energy more, and therefore mitochondrial number also more. Okay, this is the number of the mitochondria. Example, in the giant amoeba, they have presence of the 5 lakhs of the mitochondria. Second example, in the sea urchin or the egg, they have presence of 13,000 to the 14,000 mitochondria. Then third example is the renal tubules. In the renal tubules, 300 to 400 mitochondria are present. Okay, in the giant amoeba is the whole animal, right? It is a single animal of the whole animal, and in the whole animal, many types of the reactions are carried out, or the many types of the metabolic activities is carried out, and therefore they require more mitochondria. Okay, but in the renal tubules, they have presence of the 300 to 400 mitochondria, because the renal tubules, it is a cell, right? And these renal tubules, they are present inside the renal, means the kidney. Okay, they are present inside the kidney. Okay, and therefore they require the minimum number of the mitochondria. Got it? Means giant amoeba is the whole animal. Okay, in the whole animal's body, many type of the reactions occur. Okay, but the renal tubule, they are the cells. Okay, and in the single particular cell, less number of the reactions are carried out, and therefore they require the less number of the mitochondria. Okay, and then the number is less in the plant cell than the animal cell. Okay, the mitochondria are more in number in the animal cell, and in the plant cell the number is less. Okay, then next is the position. Position means actual location of the mitochondria into the cell. Okay, where they are occur, or where they are located into the cell or into the cytoplasm. Okay, in this position, the first, they are present or distributed into the cytoplasm evenly. Means they are present in the cytoplasm and they are distributed evenly into the cytoplasm. Okay, then they are also aggregated around the nucleus. Okay, means they are present surrounding of the nucleus, and they are formed in the aggregation, that is they are present in the roots. Okay, and in the paramecium, they are located beneath the cell surface. Beneath the cell surface means they present behind the cell surface or below the cell surface. Okay, this is the position. Okay, in this, the position of the mitochondria. This is the mitochondria, and also this is mitochondria, this mitochondria, and also these are the mitochondria. Okay, means they are evenly in the first point. They are present or distributed in the cytoplasm evenly. Okay, means on this corner, then this corner, that is the mitochondria. They are present evenly into the cell. Okay, then next third point, that is the fourth point, that is the structure. Okay, means actually the mitochondrial structure, or they see as a filament like. Okay, then the first point, they are bound or surrounded by the two membranes. Okay, means in the mitochondria they have presence of the two membranes. Okay, and these two membranes, that are the first is the outer membrane and the second is the inner membrane. Okay, outer membrane means they are present outside the mitochondria. Okay, outside the surface of the mitochondria. Okay, then each membrane is 6 mm in thickness. Okay, means the outer membrane, the size of the outer membrane is the 6 mm. Then also the inner membrane, the size of the inner membrane is also the 6 mm. Okay, then the space between these two membranes is called as the intermembrane space, and they forms the outer chamber. Okay, means the two membranes, that is the, for example, these are the membrane, right? Okay, this is the first membrane, this is the second membrane, this is the outer membrane, and this is the inner membrane, right? Okay, in these two membranes, the space is present, and this space is called as the intermembranous space. Okay, means the space between outer and the inner membrane, and this space is called as the intermembranous space. Okay, then and they form the outer chamber. Okay, means this space, okay, or this space or this area is called as the outer chamber. Okay, and then this space is 6 to 8 mm for nanometer width, and they are filled with the watery fluid. Okay, means this is the two membranes. In these two membranes, the presence of outer chamber. Okay, and this distance is the 6 to 8 nanometer. Okay, and this space or this empty space is filled by the watery fluid. Okay, then this is the structure. Okay, in this is the intermembrane space. This is the intermembrane space. That is this is the outer membrane. This is the inner membrane. Okay, means this yellow color, this is the red color is the outer membrane, and this yellow color is the inner membrane. Okay, and in these two membranes, the presence of the space, right? And this space is called as the intermembrane space, and they form the chamber, and this chamber is called as the outer chamber. Okay, this is the outer chamber of the mitochondria. Then the inner membrane contains a enclosed space is called as the inner membrane space or the inner chamber. Okay, means inside the inner membrane they have also contained the space. Okay, and this space is called as the inner membrane space, right? Okay, means two spaces are present. First is the inner and outer membrane, and second is the present inside the inner membrane, and this space is called as the inner membrane space, or it is also called as the inner chamber. Means in the mitochondria two chambers are present. First is the outer chamber and the second is the inner chamber. Outer chamber is present inside the outer and the inner membrane, right? And the inner chamber is present inside the inner membrane. Okay, and the inner membrane forming a series of the infolding, and this infolding is called as the pistil. Okay, now the cavity of the pistil called as the interpistil space and continues with the intermembranous space, and the inner chamber is filled with the dense, then homogeneous, then gel-like material, and this material is called as the mitochondrial matrix. Okay, in this figure, show the figure. In this is the outer membrane. This is the inner membrane. This space is called as the outer chamber. Okay, then inside the outer chamber, or this is the inner membrane. Okay, in the inner membrane, presence of this space. Okay, and this space is called as the inner chamber. Okay, and this inner chamber, they are enfolded, and this enfolded structure is called as the cristae. Okay, this is the cristae. Okay, and the inner chamber filled with the dense, homogeneous and the gel-like materials, and this materials is called as the mitochondrial matrix. Okay, means these are the content of the inner chamber. Okay, and in this inner chamber, and this content are called as the matrix granules. Then this is the cristae, then presence of the ribosomes, then presence of the matrix, then presence of the F1 particles. These are all these structures are called as the mitochondrial matrix. Okay, these are the mitochondrial matrix. Then next is the mitochondrial matrix contain the dense granules, and they have the 55S ribosome, that is the 35S and the 25S. Okay, means all of you know the two types of the ribosomes. In the prokaryotic, the presence of the 70S ribosome. Okay, and in the eukaryotic, the presence of the 80S ribosome. But in the mitochondria, the presence of a ribosome, and this ribosome is the 50S ribosome, and they have the two types of the subunits. The first subunit is the 35S, and the second is the 25S. Okay, 35S is the large subunit, and the 25S is the small subunit. Okay, and then the outer surface of the outer membrane and the inner surface of the inner membrane covered with the thousands of the small particles, and this small particle is called as the F1 particle, and also it is called as the oxysome, and it is also called as the elementary particle. Okay, and these particles, they are involved in the ATP synthesis. Okay, this F1 particles, it is the main part of the mitochondria, because the metabolic activities or the synthesis of the ATP molecules, they are occur inside the F1 particle. Okay, and therefore it is called as the F1 particles, then also called as the oxysomes, then also they are called as the elementary particles. Okay, then the two particles are placed at interval of 10 nanometer on inner surface of the inner membrane. Okay, means the distance between the two F1 particles, which is the 10 nanometer. Okay, and the single mitochondria has about 10,000 to 1 lakh F1 particles. Okay, their number is the 10,000 to the 1 lakh. Okay, means it depends on the metabolic activities of the cell. Okay, then in those cells, they have the more metabolic activity, they contain the more F1 particle. Okay, and those cells, they have less metabolic activity. That type of the mitochondria, they contain less number of the F1 particle. Okay, okay. In these brown colors, they are the F1 particle. Okay, and these F1 particles, they are present on the cristae. Okay, and the cristae means they are the enfolding of the enfolding of the inner membrane, right? Means the F1 particles, they are present on this cristae, and cristae is the inner membranous part. Okay, or the enfolding of the inner membrane. Okay, that is this structure is called as the F1 particle, or also called as the oxysome, or also called as the elementary particle. Okay, then the F1 particles are of two types. Okay, means in this the first type, that is the subunit of the parson. Okay, in this the present on the outer membrane, and they are the stalkless. Okay, means the subunit of the parson, they are present on the outer membrane of the mitochondria, and they are without stalk. Okay, means the stalk is absent. Okay, and then they are hollow, cylindrical, then 60 angstrom in long and the 60 angstrom in wide, and the central hole is the 20 angstrom. Okay, this is the size of the F1 particle, that is the sub-unit of the parcel. Okay, and they contain the enzymes, and these enzymes they are used in the Krebs cycle. Okay, and then the second part or the second type, that is the sub-unit of the Fernandez-Morgan. Okay, in the Fernandez-Morgan, they are present on the inner membrane and they are stalk particle. Okay, means the first is the sub-unit of the parcel. They are present on the outer surface of the mitochondria and they are the stalkless. Okay, but the sub-unit of the Fernandez-Morgan, they are present on the inner membrane and they have the stalk. Okay, then they consist of the base piece, stalk and the head piece. Means the Fernandez-Morgan, they are divided into the three parts. First part is the base piece, then second is the middle stalk, and the upper end is called as the head piece. Okay, then they contain all enzymes for the electron transport and also oxidative phosphorylation. Okay, means in this type the electron transport and the oxidation is occurred, that is the ATP synthesis is occurred into the Fernandez of the Morgan sub-unit of the sub-unit of the F1 particle. Okay, then they have the four complexes. Then first two in the base piece and the third and the fourth are present in the stalk and the head piece respectively. Means they have the four types of the complexes, and out of these four, the two complexes they are present in the base piece and other two they are present in the stalk and the head piece. Okay, then this is the structure of the F1 particle. Okay, in this structure, okay, this is the subunit of the Fernandez-Morgan. Okay, in this structure, this part is the base piece, then this is middle is the stalk, then this is the head region. Okay, means this is the part of the Fernandez-Morgan. First is the head, then this is the stalk, and this is the base. Okay, and this structure or these particles they are present on the inner surface of the mitochondria. Okay, and second and the first is the subunit of the parcel. They are present on the outer surface of the mitochondria. Okay, this is the structure of the F1 particle. Okay, then also this is also a diagram, and this diagram is the F1 portion. Okay, in the F1 portion, this is the F0 portion and the F1 portion. Okay, and this structure is present inside the mitochondria, or they are present in the inner surface of the mitochondria. Okay. Then also this is also a structure. In this structure, this is the base. Then this is the stalk, or it is also called as the pedicel, and this is the head. Okay, this is the actual structure of the F1 particle. Okay, in this is the F1 particle. This is the pistis. Means this shape, this structure is the pistis. That is this is the inner membrane, and this is the outer membrane. In the inner membrane, the presence of this yellow structure is called as the F1 particles. Okay. Okay, this is the structure of the mitochondria. Okay, in the structure of the mitochondria, especially they have the two types of the membranes. One is the outer and the second is the inner membrane. Okay, in the outer membrane and the inner membrane, they have the space. It is called as the outer chamber. Okay, inside the inner membrane also is contain the space, and this space is called as the inner chamber. Okay, in the inner chamber or the inner surface is folded structure, and this folded structure is called as the pistis. Okay, then on the pistis, the presence of the particles, and this particle is called as the F1 particle, or it is also called as the oxysome, and it is also called as the electrical particle. Okay, and their function is the ATP synthesis. Okay, and then also the F1 particles they are divided into the two types. First is the subunit of the parcel, and the second is the subunit of the Fernandez. Okay, what is the difference between these two? The first, the subunit of the parcel, they present on the outer surface. Then Fernandez is present on the inner membrane. Then the subunit of the parson, they do not have the stop. They have the stopless. And the subunit of the Fernandez Morgan, they are the stopless. Okay, and they presence of three types of the part. First is the base, then second is the stop, and the third one is the head. Okay, this is all about the structure.